So in this video, I'm going to show you how to solve differential equations. So what I mean by this is, in example 1, this is a differential equation because we have dy over dx. And when we solve this, we get y as a function of x plus a constant. So what we're going to do is we're going to go from this differential equation to writing y in terms of a function of x. Okay? So we're going to use a process called separating variables. What this means is we write the y terms separately to the x terms. So in this example, we'll have the y terms on the left-hand side and the x terms on the right-hand side. So we'll begin by moving this x plus 2 to the right-hand side. So we get dy by dx is equal to 1 over x plus 2. And now we'll move this division of dx to the right-hand side. So we get dy is equal to 1 over x plus 2 dx. And now because we want y, we need to cancel out this derivative of y. So we're going to take the integral of both sides. We'll integrate dy and we'll integrate 1 over x plus 2 with respect to x. So when we integrate dy, the integral and the d will cancel, so we're left with y plus a constant term. And when we integrate 1 over x plus 2, we get the natural log of x plus 2, again, plus a constant term. Okay? So the next thing we can do is we have a constant here and a constant here. Well, these just form a single constant. So we could write this one as y is equal to the natural log of x plus 2 plus a single constant. So rather than having 2 of them, we've just got 1 of them. And now this is a perfectly valid final solution, but we can write this a little bit tidier. If you consider this constant, we can write this as the natural log of a different constant. And the reason why we do this is we can now apply the rules of logs to tidy these up. So now we have y is equal to the natural log, and we'll apply the multiplication rule, so we can multiply this by that. So k lots of x plus 2. So this is a general solution to this differential equation. Okay? Let's try example 2. Okay, so for example 2, we've been asked to find the general solution of dy by dx is equal to 1 over y cos x, where y has to be greater than 0. Y cannot be 0 because then you'll have 1 divided by 0, which is undefined. Okay? So it's always good to keep an eye out for things like this. So again, we're going to use the method of separating variables. So we'll move this 1 over y to the left-hand side by multiplying both sides by y. And we'll move this division of dx to the right-hand side by multiplying both sides by dx. So now we get y dy is equal to cos x dx. And now we need to cancel out this dy and dx. So we'll take the integral of both sides. The integral of y is 1/2 of y squared plus a constant. And the integral of cos x is sin x, again, plus a constant. We'll put these two constants together, so we have 1/2 of y squared is equal to sin x plus c. And now we'll cancel out this half by multiplying both sides by 2. So y squared will equal 2 sin x plus c. Now technically I could have written that as 2c, but 2c is still just a constant, so I'm leaving it as c for now. And then the next thing I need to do is to cancel out this square term So I'll take the square root of both sides. So y is equal to the square root of 2 sine x plus a constant term. And it's not plus or minus because we're told that y has to be greater than 0. So this is just a positive. Okay, let's try one more example. Okay, so finally in example 3, now we've been asked to find the differential equation. So we've been given x equals 1 and y equals 2, and these two values will allow us to find the value of a constant term. So again, if we separate the variables, we'll move this division of y to the right side and this dx to the left-hand side. So we get y dy is equal to 1 over x squared dx. And it's easier in this example to write 1 over x squared as x to the minus 2. So I'll just rub that out and we'll put x to the minus 2. It's easier to leave it in this form to differentiate and integrate. Okay, so now we're going to integrate both sides. And what we get is the integral of y, again, is 1/2 of y squared plus c. And the integral of x to the minus 2, well, we add 1 to the power, so x to the minus 1, and then divide by the new power, plus a constant. So I'm putting these two together, and we get 1/2 of y squared is equal to minus 1 over x, plus the constant term. So now is a good time to substitute in x equals 1 and y equals 2. So I'll just write this down here. And this is to find c. So we have 1/2 of y, which is 2 squared, is equal to negative 1 over 1 plus c. So 1/2 of 4 is 2. So c must equal 3. So now I'm going to put this 3 back into our equation here. So we get 1/2 of y squared is equal to, and I don't want to start with this negative, so I'm going to write this positive first. So 3 minus 1 over x. This should be a 2, not a y, sorry. Okay, so now I'm going to cancel out this half. Again, y squared is equal to 2 lots of this. So 6 minus 2 over x. And then we'll take the square root. So y is equal to plus or minus the square root of 6 minus 2 over x. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.